This video is going to talk about node voltage method special case where we have a dependent source and how do we deal with dependent source. And the only thing that happens in dependent sources is basically we add a new variable that is tied either to a current or a voltage somewhere else on the circuit. In this particular case, we have this current source is 4 times whatever V is, and that's basically its function. Now, so how do we go about doing that? Basically, we follow everything we've learned previously about node voltage method, which means first thing we got to do is we got to find out how many essential nodes we have, and by now we know that this has got 3. And so we've got V reference here. Let's call this one V1. Let's call this one V2. And we're ready to go. Now, so in this case, we are able to determine the currents in every one of these nodes. So there's no mystery. Some are a little easier to figure out than others. But again, the process is very much like we have discussed. We have to write KCL for every node. KCL equation for every node, which is means sum of all the currents that are leaving that node, except for the reference, because we already know V reference is equal to 0. We just assumed that. Okay, so we're going to start with KCL at V1, and if we do that, we've got V1 minus 0 divided by 8,000 plus current. This current source tells us that the current is leaving. So that's 4, positive 4 Vx. If the arrow was the other way, we have to put a minus there. Plus, now this gets, again, we got to think about it. The voltage here is V2 plus 10, which means the voltage drop across here is V1 minus V2 plus 10. So this is going to be V1 minus V2 plus 10 divided by 4K, which is 4,000. I notice we always write these in volt, voltages in volt and resistors in ohms, and if that means the currents are all in amp, and so we don't have a unit discrepancy in the future. So those were the 3 currents coming to node 1. We are done with that. The only issue that happened is we introduced this Vx, and our challenge is to try to see if we can write Vx in terms of one of the variables we have, which is V1 or V2, and fortunately we are able to do that. This is referred to as dependent source equation. So in this particular case, we know Vx here, it's basically the same as V2, so this was not too bad, V2. Okay? So we're done. Now we introduced an extra variable, but we got an extra equation to go with it, so all is good. So now the next one is KCL at the other node, V2, which is going to be V2. Now this might be a little more tricky because this voltage is V1 minus this voltage. So when you write that, you got to write V1 minus 10 divided by 4,000. And you may have noticed that this is going to end up being V1 minus V2 minus 10. This is going to be V2 plus 10 minus V1. So they're negative of each other because in this case you're looking from V2. In the other case you were looking at V1. So yeah, that makes sense hopefully to you. And then plus V2 minus 0 divided by 2,000. That gives us the current through this branch. And finally, the last one is V2 minus 0 divided by 1,000 equal to 0. At this point, we've got 3 equations and we've got 3 unknown. The rest is just simple cleaning up of these equations, putting it in your calculator and getting the answer. That brings us to the end of this special case, and what this special case is, we are trying to use node voltage method, which uses KCL law, Kirchhoff's current law, And the idea here is that now we have a dependent source somewhere in our circuit, and when we have a dependent source in our circuit, we are given a new variable. So in this case, since we had 3 nodes, we get 2 equations, but we need a third equation. Unfortunately, the third equation falls out, because when you have a dependent source, you always have somewhere else in your circuit kind of relating the voltages, the unknown, to something that you already know. So that gives you hopefully a good step-by-step process of handling this particular special case with dependent source.